everyone. I think we can start. Can you hear me clearly? Okay, that's great. So today we'll have a look onto the logical design. Last week we learned about the conceptual design. Hopefully today we'll have some understanding how we will create those tables in the system that we are going to use. Okay, PostgreSQL. There I will show you how you can create all of these tables as well. But first of all, an acknowledgement of the country. I would like to acknowledge the traditional owners of Australia and recognize their continuing connection to land, water, and culture. I am currently on the land of the Buramatagal people and pay my respect to their elder, past, present, and emerging. I further acknowledge the traditional owners of the country on which you are on and pay respect to their elder, past, present, and future. Like I said, today we'll have a look on the logical design, how we'll actually create those tables that we are learning from last 2 weeks. Okay. And for that, we will learn a language called DDL, Data Definition Language. And then we will try to put some constraint, that means some conditions like primary key, candidate key, how to define those. And finally, what we have learned last week, how we can convert all of those ER diagrams that we have learned last week to actual tables. Okay, so let's start. So if you remember first week, I mentioned that we are going to learn about relational data model. So this is the person, Edgar F. Codd, who has proposed this model in 1970. Before 1970, people are using a lot of other models like hierarchical model, network models. Those models are still available and in use. Okay, so if you want to know about these models, so you need to enroll in another course. Okay, so there we teach different models. But after 1970, almost in every sector now, these relational data models are used, mainly because data representation is very simple, just tables, nothing complex is there. And it is very easy to express the queries, the questions that we are going to ask to the database. The system that we're going to use called SQL. Okay, if you are familiar with that, then you already know that that is very simple, right? So we have this idea by now that a database is a collection of relations where relation is nothing but a table with rows and columns. Right? So that is the main basic thing, that we will organize everything as a table. This idea comes from mathematical relation. Okay, so we already know, everyone hopefully knows about relation. If you don't know, that's fine. Next week, we will learn about relational algebra, the basics from where this SQL came from. Okay, so next week, we will learn how to write relational algebra as well. Okay, so a relation or a table, if we think about informally, is nothing but a two-dimensional table where we will have rows and columns. Okay, so rows are formally known as record or tuples. Columns are formally known as attributes or fields in the database sector. Okay, so this is what an actual table looks like. Here you can see the name of the table. Then these are known as attributes, which are column headings. Okay. And then we will have rows. These are also known as tuples or records. So each of these are one row, right? So this is one row. So we have 3 rows in here. That also means we have 3 tuples or 3 records. So those 3 are the same thing. Some general conventions. This is not that you must have to follow, but we normally follow this one, that we always write the table name using the first one as capital and the attribute names all small. Okay, so that is the general practice. Like you know that SQL is not case sensitive. So whatever case you use, that's fine. But this is general practice. For table name, we start with a capital letter. For attributes, we always use the small letters or lowercase letters. Okay, okay, so when we are going to write these relations formally, okay, so that is known as a schema. So when we are going to write a schema, what should we define? So we need to define 3 things. First one is the name of that relation. that means what is the name of that table, and then name and data type of each attribute. What are the attributes that are available in that table? So there's their name and their data type, okay, also known as domain. So very simple, like if I have a student table like we just have seen in the previous slide. So in student table, I had SID, name, login, address, and gender, and then their data type. Okay. SID, let's say it could be string, name, that would be string, login, string. So these are the data types that we have to mention. Okay. So if we write something like this, so this is known as a schema part. Okay. What about instance? So instance simply means a set of tuples. Okay. So set of tuples simply means we know what is tuple, right? So all the rows that we have, so those are known as an instance. So if we simply go to this example, let me draw a few things so that it makes sense. So this first part that we have, right? So this is known as the schema, right? So in schema, we write what is the table name and what are the attributes and their data type. And this row part, these are known as instance, right? Few words like not all tables qualify as a relation. Not all the table will qualify as a relation. What does that mean? We have to follow few rules, okay? Like each relation must have to have a unique name. So the table name must be unique. Two tables cannot have the same name. Someone is saying, is my internet bad or is anyone else having that problem? Or all good? Okay, a few people are saying good for me, mostly good. So let me continue. If you cannot understand or if I cut between sentences, let me know. Okay. Okay. What I was talking about is not all tables qualify as a relation. Okay. There are a few requirements like all the relation must have to have a unique name. So no two tables can have the same name. That's understandable, right? So if two tables have same name, we will have difficulty referring to them. The attributes must be unique as well. The names must be unique for those attributes. That is also understandable. And the order is irrelevant. Okay? In any order, you can write those columns in those attributes. That has no effect in our query. All the tuples must have the same structure. Definitely, tuples simply means all the rows, right? So all the rows will have the same number of columns and same thing. So they will be constructed from the same set of attributes. This is the most important thing. That is, every attribute value is atomic. Okay, so it simply means that multi-valued attributes are not allowed. Composite attributes are not allowed in a table when we are actually going to create those tables. Okay, so no multi-valued attributes, no composite attributes. Last week we learned about multi-valued and composite. Hopefully you remember. Today I will also show you a few examples of that. So every attribute value must be atomic. Okay? We cannot have one attribute which can get multiple values or which may consist of multiple parts. Okay? This condition is formally known as first normal form. Okay? Don't worry about that. Just today we'll learn about this term 1NF, first normal form. Okay. In another lecture, we are going to learn about different normal forms. There we will discuss more. Okay. Only thing that you need to know right now is that every attribute value must be atomic. So last condition is that it is a set of tuples. So every row must be unique. Okay, although the order of the row does not matter. So in whichever way you save all the rows, that's fine. Simple thing you need to mention that you need to make sure that each row is unique. If two rows are exactly same, that simply means that you are repeating the information, right? So have a look, is this a correct relation? Probably not. Okay, how many error can you find? Give me that number. Like you can say that I can find 2 errors, just not mentioning what is the error so that other people can look into it. So just in the chat box, write how many error can you find in this table based on the rules that we have seen. Okay, just write that number. Most results are coming up as 3, also have 2, few people said 4. Okay. Okay, it's like mostly 3 error. Someone said 5, 4, again 2, 3. Okay, now try to write what are the errors. Someone said 5. I'm interested to know that one. Darlington, Sydney. Yes, good. Row 1, 2, 3 have error. Dan's phone number is not there. We also have duplicate rows, name and name. Excellent. Peter Pan is repeated. Excellent. Okay, looks like you figured out everything except for one. The table name is missing, right? So the relation name is not there. So there should be a relation or table name, which would be unique. That part is missing. I'm showing you all the errors. These 2 attributes have the same name, which is another error, right? So we have to give them different names, like let's say first name and this one is last name. So the 2 attributes cannot have the same name. Another issue, you figured out that this person have 2 phone numbers, but that is not allowed, right? So Dan cannot have 2 phone numbers. If he has 2 phone numbers, we have to represent that in another way. Okay, I'll show you how you can represent that, but for the time being, this is wrong. This is also wrong because this is composite attribute. I can divide this one into 2 parts, Darlington and Sydney, right? So this is also wrong. Also, this row and this row is exactly same. So that is another error. Some of you mentioned this one. This is allowed, right? So this is correct. One person cannot have his phone number, that's fine. There is no such condition that says that you must have to fill up everything. Okay? So for this person, he does not have a phone, so it can be blank. Okay? So we have table name missing, 2 attributes with the same name, that is a mistake. Last and first have same values, that is wrong. This one is wrong as well, and this one is wrong. Hopefully those are all the errors, right? You got the idea. So this is not an correct table. Okay. So the DBMS system, or the relational DBMS system that we are going to use, it allows duplicate rows. So if you want, you will see that in the system, if I include 2 rows with the exact same value, it will not complain. But we don't definitely want that. How we will control that, or how we will check that, I'll show you later when we learn about primary key, defining a primary key. Okay, so there we can see that duplicate rows will be eliminated. Okay. When we have cases like that, when we don't know that information, okay, like one person does not have his phone number, at that time, instead of blank, we will write null there. Okay. So null is special, definitely, from that value that this is null. Let me show you one example in here. Let's say this person is an adjunct lecturer, right? So adjunct lecturer simply means like voluntary lecturer, right? So he doesn't get any salary. He has no hiring date. Whenever he wants, he starts, he takes how many courses he wants, right? So for that person, this salary and this hire, these two are null, right? So there will be no information there. So when we put null, what does that mean? It simply means two things. First one is that is not relevant. Okay. For this person's salary is not relevant or not yet known. Like in the previous table, probably that person has a phone number, but we don't know that yet. Okay. So in both the cases, either that is not relevant for that person, that is not applicable, like this one, or for phone number, one person's phone number I don't know. So what should I put? In that case, I will put null as well. Okay. Someone is asking, can we explain the second point, support and order? Yep. So support and order simply means here the order in which we will enter the attributes, that order will be there. Okay. So let's say when we are creating the table and we write the attribute order as first student ID, then student name, then phone number, that order will be there in that system that we're going to use. Okay, that will be helpful when we are going to insert the data. Hopefully so far things are making some sense. Someone is asking, does the order matter? No, order does not matter. Later we'll see when we are going to insert the information or the data, then we can insert the data in any order we want. Okay. Why we are going to use null, this special thing? It has definitely some advantages, some disadvantages. Main advantage is that so that we already know what is the thing that we are going to use for blank. Okay, so we can use many different things. Someone might say, when I have a blank, I will use a negative value. Okay, so if you are using salary equal to -1, and then you are calculating the average, right? Because -1 is a valid integer value, your average might be wrong. But if we have null there, we can skip that thing, right? That we should not include this row into calculation because it got a null. Next week, we will, probably not next week, week 5, we are going to learn how to handle null. There we'll see that when I have some rows with null, that will create some problem, right? So you can understand if I am doing some mathematical operation with null, that value will not be like 5 plus null, what would be the value there? Right? So those sort of problem, how we will handle, we'll learn that. So that's why we are going to use a special thing, which is null, so that we actually know that this is blank. What is the disadvantage? Disadvantage is definitely the complication in defining many operations. Like I said, the mathematical operations that we will have. Okay. But since we already know that this is null, special thing, we can skip that one. Okay. Okay, so hopefully now we got some idea. Okay. And now we are going to actually define how to define this data in the system. Someone is asking, every row should be unique. So why DBMS allow duplicate rows? Good question. So every row should be unique. We have to enforce that condition, right? So if we don't enforce that condition, RDBMS allows that one so that it can input repeated data. But definitely we don't want that. That's why we will use some key like candidate key, primary key that we have learned. We know that primary key cannot be repeated, right? So if we declare primary key, then each row will definitely be different, not the same. Okay, so DDL, in short we say DDL or data definition language. That is what we are going to learn next. Hopefully you remember this picture. Like I said, in the first week, this picture will come up almost every week, which part we are learning in each week. So today we are learning about this part, SQL commands. Okay, so we have a front end. Front end simply means, let's think about the browser. You open up the Facebook. Okay, so you have the Facebook homepage. There you are clicking on a friend's name. So what do you get? You get to that friend's profile page, and there you get all the information of the student, right? So how do you get that? So definitely whenever you click somewhere, you are actually executing an SQL command. Okay, you are simply asking, show me the information of this person. Okay, so that is what you are actually doing. So you are actually running an SQL command, and that SQL command comes into this DBMS system. That DBMS system takes the data from the actual database and shows it to you. Right? So today we are into this part. So this week, next week, and week 5, 3 weeks, we will stay in this part, SQL command. Okay, how we can write those SQL commands. SQL command are of 3 types. First one is DDL, then DML, and then DCL. DDL means data definition language. DML means data manipulation language. DCL means data control language. Okay. Today we are only going to learn about DDL. From next week we will start DML. Okay, we don't cover DCL in this unit. So these are the 2 that we are going to cover, DDL and DML. From the name, probably you guessed something, what is happening here. So here you can see data definition language. So here we'll define everything. Define simply means we'll say, what does the table will look like? In that table, how many attributes we will have? What will be the primary key? Those sort of things. In data manipulation language, here we have data, right? We will try to manipulate that data. Okay. So we will ask the queries, we'll ask some questions, and the system will provide the answer. So that part is DML. But today we'll simply learn how to create all the tables, how to make some changes in those tables, okay, those sort of things. So DDL mainly covers creation, deletion, and modification of the tables, not the actual data. Okay, so we are only thinking about the table creation, deletion, and modification. Okay. So that is the part that we are going to cover today. Okay, so if I want to create a table, very simple, like I said, SQL is really, really simple. The command is create table. Okay. Could not be much simpler. So the command is create table, then the name of your table, and then list of columns. So if I want to create the student table that we have seen previously, so this is how it looks like, create table, then the name of the table, which is student, and then all the attributes, their data type. Okay, some data type requires the size, so we'll provide that size. Okay, so I have 5 attributes: SID, name, login, gender, and address. SID, let's say it would be integer. Integer simply means 1, 2, 3, 4, 5. Okay, numbers there. Name, it will be variable character, variable number of character, because every person's name has different number of characters, right? So that's why this one is written as varchar, variable character, but the maximum size is 20. That simply means that one name can consist of maximum 20 characters. Okay, so we have to define a maximum size for this variable one. Login, same thing, variable character with maximum size of 20. Gender with character, that simply means only one character it will allow. Okay, if you want to allow more than one character, then you have to put that number here. If you don't put anything, that simply means only one character. So for gender, we have seen M, F, those sort of things. So that's why only character. Okay? So car. And finally, address, same thing, varchar, and the size is 50. Hopefully making sense. Very simple structure to create a table. So main thing is we are actually defining the schema, right? So this is what we have learned in the schema. Then in the schema, you need to have the table name, the attributes, and their domain or the data type. Someone is saying varchar means more than one character. Yes, so varchar means maximum 20. There is no minimum, right? So if you don't put anything, that's fine, but maximum 20 character you can insert there. Someone is saying why we need to set up the limitation for each column. That is for memory management issue, right? So when we create this table and we say name without any limit, then how many memories you will allocate for that table, right? So that it can allocate the memory efficiently. That's why we are saying this limit. Hopefully that is making sense. So a lot of other data types are available. If you want to know about those data types, have a look into this link. Okay, there you will find all the data types. I have just taken few data types from that list. Okay. Definitely have a look into this link. There you will find the complete list. But some are here which are helpful, like integer. This is the one that we are going to use again and again. If you need to insert, let's say 2.5, okay, so for those sort of thing, you can use decimal or numeric or float, that's fine. We have already seen character or varchar. Blob is another one. So blob simply is used for things like image. Okay, so this is very large object. Okay, and date, time. So let's say if you want to store the date, or let's say the birth date of a person, so definitely this is the one that we're going to use. Let's say you are working on a schedule, you want to store the time, so this is the one that we're going to use. Right? So mainly these are the things that we use again and again. Varchar is the one which you will use mostly. Someone is saying, what is the difference between character and varchar? Okay, so that is the memory management issue. Okay, so varchar simply means, like I say, what is the maximum size we can have? Let's say q equal to 10, so I can have maximum 10. Character also I can say, let's say maximum 10. So it looks same, right? Character 10, varchar 10. The main difference is the memory. So when I write something in varchar and I'm saying maximum size is 10, so if you have a name, let's say the name is Adam, right? So name is Adam. How many characters I have? 4 characters, right? In here I have only 4 characters. So if I declare this one as character, let's say 10, and I'm inserting Adam. So what he will do, he will store this 4 character, and then he will fill up the rest of the 6 with the space. Okay, so he will always have the size with 10 character when I'm declaring character q. But with varchar, if I insert Adam with 4 characters, it will be 4 characters. Okay, rest of the 6 characters will not be used. So that is the memory management issue. Again, if I'm using character, then that is the fixed size. If you insert something which have less than fixed size, then he will fill up all of those using space. But for varchar, if you insert less than the maximum size, then that is the only size that you are going to get. Okay, so if you insert 4 character, it will be 4 character thing inserted there. Someone is asking decimal versus float. Mostly same thing. Okay, this float, double, these things we normally use for scientific sort of notations. Okay, you want to write 10 to the power 5. So in scientific notation, we sometimes write 10e something, right? So in those cases, we'll use float, real, or double precision. But normally, when we have something like 2.5, in that case, we will use decimal or numeric. Okay. Yeah, so go to this list. Here we'll see the descriptions as well, in which cases we can use all of those things. Okay, some examples are there as well. Okay, so hopefully everything is now ready. We have the idea about data type as well. So these are the 3 tables that we want to create. So what should that command look like, or the SQL DDL thing looks like? Think about, I first want to create the student table. What should be the command there? So we learned about create table. So it will definitely be create table, then the name of the table, right? So hopefully this thing is making sense. I'll just give you a few seconds to have a look first. Okay, probably got some idea. So student table, create table, student, attributes, and their data types. Whatever data type you want to use is applicable. In this case, you are going to use that one. Same thing for unit of study table. Data types are there, the attribute name are there, and enroll table will also have the same thing. Okay. Integer does not require any size. Varchar will always require a size. If you don't put any size for varchar, it will complain. Okay. Character depends on you. If you are only using only one character, you don't need to put anything. Okay. If you are using more than one character, then that is the thing that you have to mention. Someone is saying, does this part have to be in this position? No, there is no such thing. Okay. That means varchar is better than character because it uses right size. Yes, definitely. Varchar is definitely better than character. Okay. That will take less size than the character. Character 8, that is the thing that I explained, right? So unit code will always have 8 characters. So this is how sometimes we ensure that unit code must have to have 8 characters, or let's say phone number. Phone number must have to have 10 characters, let's say. Okay? So we can ensure things like that using character 8. Okay, so we have created a table. I will later show you at once, okay, in the system how we can create. So let's say we want to delete the table that we have created. So the command is drop table. If I use drop table, it simply means it will delete the table with all the tuples. Remember this thing. So drop table is really dangerous thing, right? So if you use drop table, the schema information will be deleted. The table will be deleted with all the data. Remember that. So all the data, so everything will be destroyed for this table. But if, let's say, I simply want to delete the data but not the table, that time we have to use something else. I'll later show you today. But drop table will destroy the student table. Okay, there will be nothing there. Remember that. We're definitely going to make some mistake in the table that we are creating, so we want to make some modification. Let's say I want to add a column. I can do that. Okay, so if I simply want to add a column into an existing table, I have already created the table. Let's say the student table I have created with SID and name. Later, I want to store the email address of the student. Okay. So I don't want to destroy and then create again. So what I can do, I can simply alter the table. Alter table will let me insert some columns or remove some columns, whatever I want to do. So alter table, the name, this means the name of the table. Okay, so alter table, let's say student, add column, that is the command, and then the column name and their data type. We can add some constraint. We have not learned about constraint yet. Later part today, you will see how to add constraint. So yes, if you want to put some more constraint in a table, we can do that one as well. Okay. Few other things are available in here. Let me show you that one. I'm not sure how to remove this pointer now. Let me just end this one. Sorry for the noise. And I want to show you so that you can later figure it out quickly. What is the thing that we can do? This page will be really helpful. So we can add a column. We can remove a column. We can add some constraint, remove constraint, change the default values, change column data type, rename any column, and rename any tables. Okay. So go through this page. Here you will see examples as well. Okay. So all the examples are there. What can be done and how it can be done. Okay. Today I will also show you a few. Once I go through this part, okay, then I'll show you. And during your tutorial, you will definitely have some time to practice all of this. Okay. Okay, so we can modify a table. So let's say I want to rename one column. So how to rename one column? So alter table customers, rename column, that is the keyword that you are going to use. Let's say I have credit limit. I want to change that one to credit amount. Okay. So this is the name of the table. Then this is the old attribute name, and this is the new attribute name. Very simple, should make sense. Again, I want to add a column. into a table, let's say countries. So alter table, then the name of the table, then add column, that is the keyword, then what is it that you are going to use. Okay. So someone was asking about decimal. So here you can see numerical. So same thing will be there. So it will be decimal, okay, instead of numerical, and there we will pass, let's say 2 and 2. Does that mean we can add constraint to the student table as well? Yes, we can put any constraint in that student table. Let's say I want to define a primary key. In that table, I didn't create any primary key, right? So after I create the table, I figured out that I need to define a primary key. So primary key is a constraint. So we can add that constraint later. What's 2 and 2 stand for? So that is the data type thingy. So have a look in here. So fixed point number with precision P and Q decimal points. Okay. Does that make sense to anyone? What does that mean? Yep. So Q decimal points. So after decimal, how many places we will have, right? So in this case, we have Q places, and what is the precision in that? Okay, like I said, go to that page. There we'll see more explanations for that one. Okay. Okay. So now our table is ready, hopefully, right? So we have created the table. If needed, we can make some modifications in that table. And finally, our table is now ready where we can insert some data. So inserting some data, what should be the command? Very simple, insert into. So insert into, then the name of the table. Then this part is optional, list of columns. If you want to write, that's fine. If you don't want to write, that's fine as well. Why? I will explain in here. But then the keyword is values, and then the actual value that you want to insert. Okay. So let's say in student table, I want to insert these two. So this is the SID and this is the name. Okay. So insert into student values, SID and name. I want to insert using name first, then SID, then this for items. Just looking into these two examples, which one will you prefer? I'll explain later which one is better, but what would be your preference between these two? This is, let's say, number 1, this is number 2. Which one you are going to use, you think will be better? Great. Everybody is saying number 2. Any reasoning why? I got one person who is saying 1. Other than that, everyone is saying number 2. Any reasoning why you think number 2 will be better? Someone is saying it's clear what the content is. Yes. Yep, it's much more clear. Okay. So that is the reason. Yes. So in student table, if I'm inserting values without using any column list, right? So I have to remember the order. So when I'm inserting into student table, I need to remember that first I have to put SID and then I have to put the name, right? If I first write the name and then put the SID, he will definitely gonna complain. Because in the student table, first he is expecting SID, but if you put SID in the second place, he will definitely complain because he does not have anything. But if I definitely want to change the order, like I want to first insert the name, then the SID, this is what we can do. Or if I simply want to does not include the value of some attribute, using this way, right? If I simply ignore that one, let's say I have SID and name. For this student, I simply want to insert his SID, not his name. So I can simply write SID and simply this one, right? So he knows that this is the SID value you are sending. So he will insert that value in SID and name will be null in that case. Okay, I'll show you an example of that one. Someone is saying, does the order matter for number 2? Again, if you put name here first, so here first you have to put the name. Second is SID, the second must be SID in this case. So in which order you are writing in here, the value must correspond to that order. right? Again, after inserting the data, we will have some mistakes. We will want to modify whatever we have inserted there. So let's say one student's address I want to update. So the command is update, then the name of the table, then is the keyword set, in which columns value you want to change. So here it is. So set is the column name equal to what is the new. You don't want to change the address for all the students, right? So I want to change the address of this student only. So this is what I am going to say: update student table, set address equal to this for this student. This for thing we are going to use where. Okay, so any condition that we are going to write will be insert this where SID equal to this one. So this one will change only one student's address, okay, to this new address that we have. If we want to delete some tuples or all the tuples, at that time we have to use delete from. Remember, previously we have used drop table. So drop table will remove everything on the schema as well. But if I simply want to delete, let's say, one row, okay, so we can do that using this where column. So here I have delete from student where name equal to Smith, hopefully making sense. Where the student name is Smith, delete only that row. Every other thing will be there. Okay. Someone is asking, is it necessary to put primary key in where part? Yes, but since we have not learned how to declare a primary key, that's why I'm not saying that for the time being. Okay, but later we'll clarify. So any conditions you want to put, you can put here. Node is there. Okay, but definitely it's better to put primary key. But we have not learned about primary key, how to create primary key. That's why I'm not mentioning there. Someone is saying in the previous slide, the option 1 will be wrong since it does not follow the order of attributes. Yes, if you don't follow the order of attributes, it will definitely be wrong for option 1. Okay, so before going to integrity constraint, let me create few things so that okay, so that you can understand this one better. So let's say I want to create a table. So this is what the software looks like. Hopefully you already have some idea, right? So we want to create a table. Let's say create table students. What are the attributes that I have to write? Let's say SID. This one will be integer. Name will be factor. I need to put a size. Let's say 10. Any other attribute we can think of? Let's say phone, which will be integer. That's it for the timing. Sorry, that should be comma. So if I simply write this one, you can see that I have written these in capital letters. That is not necessary. Okay, like I said, SQL is not case sensitive. Any order, let's see if I write in this way, some small, some capital, that's fine as well. Okay. Someone is saying, why don't you type everything in one line? Yes, you can do that. Those things have no effect, just for visibility so that we can understand nicely, okay, see everything clearly. That's why I'm writing in different lines. You can write in everything in one line, that's fine. Is there any accepted style guide to follow or no? No, there is nothing. So SQL is very flexible. You can write it any way you want. Okay, so if I simply run this one shows that yes, table has been created. Okay, so query has been run successfully, table has been created. Where is that table? So I'm working into this one. Okay, so if I go to databases, I already have few other things, but we have created a student table today. Hopefully, I need to probably do a refresh. So here you can see that this is the table that I have created just now. students. Okay, so if I click on columns, I can see SID, name, and phone. SID, name, and phone are there. Someone is saying we have to add a semicolon at the end. Yes, so semicolon means that that command is finished. Okay, if I have only one command and I remove this one, that's fine. But later when we write a lot of commands at the same time, at that time we distinguish them using the semicolon. Okay, so semicolon means that command has been finished. Okay, now you can see that yes, I can create this table. So let's say I want to add another column into this table. What would be the command? Can you write in the chat box? I want to add email into this students table. What would be the command? Can anyone write? I will simply copy paste from chat box. Email data type would be varchar, right? Any size you can provide, that's fine. Someone is saying, is name a keyword in SQL? Yes, it is a name, but it doesn't complete. Okay, it will let us use that one. No issues. I'm waiting for your response. Anyone? Okay, someone wrote, I'll simply copy paste and then see whether that works or not. So this is what I've got from chat box. Alter table student add column email varchar 20. Let's run. Yes, excellent. Everything was fine. If I refresh, I'll see email there. Right? So thank you. So now you got that idea. Yes, I can alter that table. I can add one more column. If I want to add more columns, I can do that, right? If I want to rename anything, I can do that one as well. Okay, so all those commands are in here, what I have to use. Okay, let's say I want to insert one data. I want to insert SID 123, name Adam, phone 12345, and email abc@def.com. What would be my command if I want to insert? Again, can anyone write in the chat box? I'll copy paste. This is the thing that I want to insert into a student table. Excellent job. Someone written. Okay. Insert it to students. These are the values. If I click, you can see that yes, that value has been inserted there. Don't worry what I'm running here, writing here. This is just to show you what does the table looks like. Later we'll understand what does this means. So if I run this one, so you can see yes, everything is fine. SID equal to 123, name equal to Adam, phone number 12345, email is this one. Right? Hopefully making sense. This was the command that I have used before to insert that row. Someone is saying update. No, I didn't have any data, so I need to insert, right? So insert into students, then the values. Why don't you add column names as option 2? Yes, you can do that if you want. So that's what you will do here. So you will simply write SID, let's say name, phone. Let's say I don't want to put email address. Okay, so this is what I can do. Let's say the person is Bob, phone number is something. I don't have an email address. If I run, now you can see that yes, this email address is null by default because I didn't provide any email address, and all the other things are there. Okay, hopefully making sense. In the tutorial, you will have opportunity to work on this one as well. Okay. Someone is saying, what if, whatever reason, the name was blank? Yes, you simply don't put that one in here. That's it. So that is the benefit of putting all of these names in there, right? So if I simply run this one, you can see name is blank, no issues there. If we have email address in the front and do not insert in the end before value, but we put email after value. Yep, so any order is fine. So that's why we're writing this one, right? So let's say first I write email, then phone, then SID. I skip that. So since I'm defining these attributes, right? So that is the benefit of. So let's say this is the email address 123@456.com. Then on phone number, whatever number we have, one SID is. I need to put inside this. Sorry about that. If I compile, now you can see that yes, everything is in the right place. So this is the email address 123@456. This is the SID. So he put everything in that order. Right? So like I said, in the tutorial, you will have some opportunity to work on this. Okay. So hopefully, just I wanted to show that yes, you can put those command and everything will be there. Okay. Okay. So now we have created that table. Hopefully everything is making sense. You want me to go on or take a break? Now, probably go on a little bit. Okay. Then I'll give you that break. Okay. So integrity constraint. How do we put those conditions like primary key, foreign key, or sorry, candidate key sort of thing? Foreign key, you don't know. Okay. So integrity constraint, we have already inserted a condition, probably didn't realize, but we have already put a condition which is the domain, right? So when you say, let's say, phone number equal to integer, there definitely you cannot insert characters, right? So that is one condition. So that is definitely one condition that we have already inserted without realizing. So that is one integrity constraint. In short, that is known as IC. So this is the term you will hear from me, IC. Okay? IC simply means integrity constraint. Any other conditions that we want to mention, we can mention that. So we can specify any conditions. And when declared, this will always be checked. Okay? So whenever you are trying to insert one data, you will definitely check if the data type is integer, whether that is integer or not. So those sort of checking will always be. Okay. Definitely the legal instance is when we satisfy all the conditions. So only then the system will allow you to insert or update that data when you are satisfying all the constraints that we are going to have. Okay. So next constraint that we're going to put is key. We already have some idea about key. New thing today will be foreign key. We'll learn about that, but we already have some idea about keys, primary key, candidate key, those sort of things, right? So if you remember the definition, what is the definition of candidate key? The minimal set of attributes in a table which can uniquely identify each row. So two things, set must be minimal and it should uniquely identify each row. Two things you need to ensure. Okay. So keys can be simple or can be composite. So the candidate key that we are going to define, it can be simple, consists of only one attribute, let's say SID. Okay. Can be composite, multiple attributes could be there. Like if you remember the second example that we had during the last lecture using house, there we are struggling what should be the key, right? So we choose house number, street name, suburb, everything together as a key. So that would be a composite key when we combine multiple attributes. Or if you simply have, let's say SID, that would be a simple key. Okay. So which set of attributes can be a key? Definitely these two conditions, that it should uniquely identify. No two distinct tuples can be same, and this is not true for any subset. That simply means it should be minimum, right? So these are two conditions must be satisfied for declaring one attribute or combination of multiple attributes as a key. What if this second condition is false? Let's say second condition is false. That simply means this is not minimal. This is a set of attributes that can uniquely identify. Does anyone remember what does that key calls? What is the name of that key if this second condition is wrong? Simply the set of attributes that can uniquely identify each row. Yes, excellent. 3 answers I have got, and all of those are correct. That is known as super key. Okay. If the set of attribute is not minimal, it can only uniquely identify. That thing is known as super key. Okay. Good. Okay, how we can define candidate key and primary key? So primary key we must have to define for a table. So each table will have only one primary key. So what is primary key? Nothing but the key that you have chosen from the set of candidate keys. So in a table there can be multiple candidate key. From those candidate key, whatever is chosen by the DBA, that means you, any candidate key you can choose. There is no hard and fast conditions there. That will be known as the primary key. And for each table, you must have to define a primary key. Next thing that we are going to learn new today is foreign key. What does foreign key means? So we are familiar with this word foreign, right? What does foreign means? Let's say I came to Australia from another country. So in here, I am known as a foreigner, right? So when I'm in Australia, I am a foreigner. I came from another country. So when I came to this country, how do they distinguish who I am? Definitely, I have a unique number somewhere. So, and that is my passport number, right? So for each foreigner, we have a passport number. So that passport number belongs to my country, right? But when we came to Australia, that is the number always will be used to identify me, right? So that thing will be known as the foreign keys. So it comes from another table. From where it comes, that table is known as the parent relation or parent table. Okay, and it works like a logical pointer between two tables. Now you can see with my country, with Australia, there is a connection between these two using my passport number. Right? So using my passport number, I can, or someone from Australia can get all the information from my country, and the other way around as well. So that thing is known as foreign key. So when we take one attribute of a table and put that into another table, that one is known as the foreign key. Hopefully things are making sense. Can anyone identify any foreign key in these 3 tables that we have? In which table we have foreign key, first of all? In these 3 tables, the student, enroll, and unit of study, in which table do we have foreign key? Okay, yes, you got it right. Only in this table we have foreign key. In this table, we don't have any foreign key, okay, because unit of study code, that is its own attribute. The student table SID, that is its own attribute, but in enroll table, we took this student ID from student table, right? So this SID actually, this is his actual home, but we took that one and put it into this one. Again, we put this unit of study code and put it into this enroll table, right? So this U code belongs to unit of study, but we took that one from there and put it in here. How do we define foreign key or show that in the table? Now probably you got that idea using this dotted line. You can see there is a dotted line here. You know what does underline means? Anyone remembers what does this SID underline code? What does that underline means? Primary key. Excellent. So underline, this means primary key. When I have dotted line, things like that, that one will be foreign key. So in this table, we have two foreign keys. One is SID, another one is unit of study code, but only one primary key, which primary key consists of these two. Okay, excellent. Yeah. Okay, so hopefully making sense. So now we have this idea of three keys. We don't define super key. We don't have to worry about that. So we'll only define primary key, candidate key, and foreign key. Someone is asking, what is the primary key for enroll? These two, SID and unit code. That's why the example in there. Okay. Okay, so these three key we are going to define: primary key, candidate key, and foreign key. For primary key and foreign key, we are going to write primary key and foreign key. That is the keyword. Unfortunately, for candidate key, we don't write candidate key. We have to write unique if we define something as candidate key. Okay, so these three keywords we are going to use. Extra thing, when you are declaring something as a foreign key, then you have to mention what is its host country, from which table this one is coming from. Okay, so the name of the relation referenced by the foreign key. Like SID is coming from student table. That's what I have to mention. Unit of study code is coming from unit of study table. That is what I have to mention. Okay. So like this is how we'll write that foreign key SID. SID is a foreign key. It references student table. Now, student table have a lot of attributes. Now, these student tables, which attribute this one is referring to, if you want to mention that one specifically, you can do that. You can write foreign key lecturer references lecturer tables employee ID. If you don't mention anything, by default, it will point to the candidate keys, or actually the primary key that you have selected from the set of candidate key. Okay, so if you are simply writing references student, so this SID will point to student table's primary key, which is SID by default. If you have something else, you want to point to something other than primary key, let's say, so you can write that one in here. You can explicitly say which attribute this one is pointing to. Okay. Why by default system know which one is FK? System does not know FK. System only knows primary key, right? So that's why we have to define what is the foreign key. So when you create a student table, we will define the PK for the student table, and that's why you will know what is the PK, right? But the foreign key we have to define. Okay, so if I have these three tables now, I want to create using this primary key and foreign key, everything that we have. Okay, so this is how we are going to write. Create table student, SID integer, name, varchar, then one constraint, and then primary key SID. This part is optional. This is simply a name, constraint student underscore PK. This is a name. This part is totally optional. If you don't write anything like this, that's fine. System will automatically give a name for it. Okay, I don't normally use this constraint. Okay, I simply write SID integer, name, something, and this is my primary key. This one will write. Same thing for unit of study table. Again, this part is optional. If you want to use, that's fine. Why we might need this one? If you want to change the primary key later, right? So at that time, you can refer this one using this name. But since system automatically gives a name to us, that's why we don't bother about that one. Okay, last thing is enrolled. How enrolled table will look like. So SID, unit of study code, semester, all of those things are there, we understand. And then we define foreign keys and primary keys, right? Foreign keys SID, reference is student. Foreign key, unit of study, reference is unit of study, and then primary key consists of these two. Right? Hopefully making sense. Again, this part is not mandatory. System will automatically do that one for us. Okay. Few things. Key constraint when we are defining this primary key, foreign key sort of thing. Someone is asking, what is employee ID? Do we have to declare PK and FK? We definitely have to define this primary key. That is a must. Foreign key, if you have foreign key, you have to declare foreign key. Okay, key constraint. If we declare some keys, what are the constraints? What are the conditions that we are putting in there? So we know if we declare something as, let's say, primary key, no two distinct tuples can have the same value in those key attributes, right? So if SID is the primary key, then no two student can have the same SID. But have to be careful when we are declaring these keys. Between these two, one will be wrong and one will be right. Just looking at the structure, can you figure out which primary key definition will be wrong? In this case, let's say this one is number 1, this one is number 2. Which one is wrong? That's what I want to know. Okay, everyone said number 2 is wrong. Any reasoning why number 2 is wrong? I got one who is saying number 1 is wrong. I want to know which one is wrong. Okay, number 1 or number 2. Few people are talking about only one primary key. Both the table have only one primary key. Both this one, number 1 and 2, both have only one primary key. So this one have primary key, which is composite. This one have only one primary key. This is candidate key, right? No, someone is saying unique condition is the issue. No, unique condition is not the issue. This is correct. This is perfectly fine. Issue is with declaring this primary key. Think about which one will be right in the real world. If I, for enroll table, declare SID as the primary key, what does that mean? That means one student can be enrolled in only one course. Can you understand that? Because SID is the primary key, right? So the table looks like SID, CID, and grade. So according to 2, let's say SID is my primary key. So if it is, let's say 1, 2, 3, and that student is in, let's say, course number C01, and he has a grade A. For this student, can I enroll him in another course? Let's say CO2. According to this definition, will this data be valid? According to this condition, will this data be valid? Definitely not. Why? Because here SID is the primary key, right? So he will not let me write this SID twice. He will say, no, you are doing it wrong, but that would not be the case. One student can enroll in multiple courses, but if I use number 1, it will be correct. Here I can see 1, 2, 3 column and C01, 1, 2, 3, C02. That one will be valid. So this one you will be valid. Someone is talking about unique. Unique means that data will be unique. That is a candidate key. I cannot repeat that. Okay. Something about my mic. Can you hear me now clearly? No? Okay, that's fine. Let's take a break. Okay, so I'm going to take a break and then we'll start again. Okay, hopefully at that time my system will work fine as well. Break of 3 minutes. After 3 minutes, I'll come back. Okay. Okay, I'm back. Again, few questions regarding this primary key. Yes, one student said it correctly. Primary key can be a combination of several attributes. So this is a composite primary key, right? So we learned that primary key can be simple or composite. In this case, we have a composite primary key. We have only one primary key, not two. Okay, these two, SID and CID, combinedly created only one primary key. Hopefully everyone is back and you can hear me clearly now, right? Yes. Sorry about the internet connections. I'm not sure why this is happening. Should PK chosen from candidate key? Yes. Should we write unique on one? No, we don't need unique on one, because primary key will automatically ensure that, right? So, okay, I think we can move on. Foreign key, understandable. If I define one attribute as a foreign key and I want to put a value in that foreign key, let's say alpha, that value must be there in the parent table, right? So parent table must have to have that value. Like I said, my passport number is my foreign key, right? So if I don't have a passport from my home country, then which passport number you are going to use? There is no way to use that one, right? So first, in the home country, I need to have a passport. Then using that passport number, I can go to any other country, right? So that is what is exactly written here. If in a foreign key, if there is a value alpha, that simply means that that value must be there in the parent table as well, okay? So in this table, we already figured out that SID and unit of study code is the foreign key, right? Knowing that information, can you answer this question? What can we say about the student relation? I'm asking how many, at least how many attributes, sorry, how many rows are there in the student table? This is enroll table. Looking into this table, can you let me know at least how many rows are there in the student table? So I'm getting varying answers. Someone is saying 2, most people are saying 3, someone said 4. 4, 0, 1, 2, 3, any number. So I said at least, right? So at least how many rows are there? 4, 3, 4, 3. Yep, that is not writing. So yep, we can see 3. This is the one, this is the one, and this is the one. These two are same. Same student is enrolled in multiple courses, right? So in the student table, there must be a student with SID 1, 2, 3, 4, another student with 3, 4, 5, 6, another student with 5, 6, 7, 8. Right? So these 3 students must be there in the student table because they are in the enrolled table. Hopefully making sense. Okay. Sometimes, like I said, the system allows us to write duplicate rows. How do we remove duplicate rows? Definitely using keys. Okay. So how to avoid duplicate rows so that there is no duplicate row in our table? Define at least one key. So if we define a key for a table, that simply means that everything will be different, right? So if we define a primary key, let's say, so is it possible to contain that table to contain identical rows? Definitely no. If no key is specified, then what can we do? No key here simply means no primary key, no foreign key has been declared. We can definitely use candidate key using this keyword called unique, right? So we have learned that one. So using unique, we can specify that everything will be different using unique for entire set of attributes. For every attributes that we have, we take the whole set and say that whole set will be unique, right? So that there is no duplicate rows in the table. Hopefully making sense. So main thing is that we have to declare at least one key, and that key will be primary key. Okay. So for every table, there will be a primary key so that there is no duplicate rows. When we declare some key, okay, so at that time, this null or not null, we have to define whether some attribute can allow null or not. So let's say I have an attribute called phone number for a student. Can that be null or not? If you allow some students without a phone number, okay, so we can write null. If we don't allow that one, if you don't allow that one, that every student must have to have a phone number, at that time we can write not null. Okay, let me just show you an example. This is very simple. So SID, in the student table, every student must have to have an SID, right? So that's why I'm writing integer not null. That simply means in here you cannot put blank. Okay, you must have to give me a SID. You must have to have a name. You must have to have your login information. Gender, birth date, that is optional. So that's why no information is there, so it can be null. Hopefully making sense. So whenever we fill up a form, we see few fields are mandatory, right? Few fields are optional. So that mandatory fields are written as not null. Now you understand. So if SID is defined as not null, and when I'm inserting the data, I'm not putting any SID, it will complain and say this is an error. You must have to provide an SID. Hopefully making sense, not null and null. Okay, how it behaves with keys. When we define one primary key, okay, up to 1, that means maximum 1, right? And it must be unique. It automatically disallows null values. Remember this very important piece of information. Primary key automatically disallows null values. So if you declare SID as the primary key, you will not be able to put any null in there in an SID, since that is a primary key. Unique, when you use unique as to define candidate keys, okay, so the system that we are using, it will allow a single null but disallow multiple null values. That simply means for an attribute you will be able to use null at most once, okay, one time you can use null, but you will not be able to repeat null again and again for that particular attribute. Foreign key by default allows null value. So this is the main difference you need to remember. Foreign key allows null values, primary key disallows null values. Okay, so that is the main thing I want you to remember. That will be very helpful. Sometimes we forget, that's why system does not behave. PK disallows null value, foreign key allows null values. Okay, remember that thing. If you don't want this, then you say not null. When you are writing foreign key, if you don't want null, you specifically have to say not null. For primary key, you don't have to do that because it automatically disallows null values. Hopefully making sense. This is very important piece of information. Primary key disallows null values by default. Foreign key by default allows null values. Okay. Okay, we are not going to take a break. Any question? Does table have to get a PK? Yes, every table must have to have one PK. Is it possible to declare a composite of attributes unique? Yes, that's permissible. You can declare a lot of attributes as set as unique. Any other question, anyone? So this is what we have learned, okay? How to create the table, how to declare the constraints, everything that we need to know, we have already covered that. Now I will simply cover what we learned last week, the diagrams. From the diagram, how can we convert it to actual table? Okay, so this part will be easy. Last week we learned about ER diagram, and today we learned about how to define the tables. So how to come from ER diagram to relation. This is what we learned today. This was last week. Could we explain super key versus unique? So super key simply means it cannot be, it need not to be minimal. When we define something as unique, that means candidate key, that must be minimal. Unique allow nulls. So for unique, the condition is this one. It allows a single null. You can write null only once, but it disallows multiple nulls. If PK can composed of multiple attributes, why we need candidate key? So that would be minimal, right? If PK is composite of multiple attributes, but again, that would be minimal. So let's say SID and name, for the sake of understanding that SID and name is my primary key. All the SID only could be primary key, okay? Bad example. Any other example, let's say house number. Last week, we learned about house number and let's say house street. These two will form a primary key. Okay, but in that table, I also have house owner's phone number. Okay, so that could be a candidate key. You can define that one as a unique, right? But you can still have a primary key using multiple attributes. Okay. No other question looks like. Let me move on. Like I said, during the tutorial today or tomorrow, depending on your schedule, you will practice all of these things that I have talked about. Okay, so you actually implement all of these things. So there you will see. Okay. Hopefully you were here during last week's lecture. So this is what we have covered. All of these things. Today we'll simply learn how to convert all of this into actual table. Okay, so we learned about entity set, match the name with weak entity set. We define this one as a strong entity set or normal entity set. Okay, then we learned about weak entity set, relationship. There we learned about primary key, candidate key, participation constraints like is a hierarchy and aggregation. These are the things that we have learned last week. Today we'll simply learn how to convert all of these into tables. Okay, simple thing. Each entity set becomes a relation, that means becomes a table. Okay. Column correspond to attribute, rows correspond to entities. Okay. So column simply means the attributes that we have defined last week, and rows simply means the values that we will have. All the attributes will be simple. That's what we have learned, but last week we have seen that attributes can be simple. So if there is a simple attribute, we'll simply directly map that one into a table. If one attribute is composite, which is allowed in ER diagram, right? So in ER diagram, we can show composite attribute, but in table today, we learned that that is not permissible. So what we have to do, we have to use only their simple components as an attribute. Okay, so address can have, let's say, suburb, street name. So we have to use all of them separately. If we have multi-valued attribute, which was allowed in ER diagram, if we actually convert that one into table, we actually have to create a new table. We have to create a separate relation. Separate relation means we have to create a new table because multi-valued attributes are not allowed in actual table, right? So that is what we have learned, that composite and multi-valued attributes are not allowed when we are going to create those. Let's see an example. Hopefully things will make sense. Here, employee is the table. Okay. Can anyone write what would be the schema? So you don't have to write the data type. Simply write for employee what will be the attribute. Okay. Within bracket, just write what is the attribute. Any other table that I have to create for this one as well. And what would be that attribute? Okay, I'm not sure whether you are writing or just waiting to show me the answer. I'll show you the answer. That's fine. If you're writing, that's fine as well. You can match with that match with the solution. So in employee table, we'll have this. Have a look. We have employee ID, we have name, we have no address because address is the composite attribute. So we have street, city, state, and zip code. I don't have any skill because skill is a multi-valued attribute, right? So what do I have to do? If this is a multi-valued attribute, I have to create a new table. In that table, I'll put skill. And how do I connect with the employee table? Using the primary key as a foreign key in that table, right? So skills, new table I have to create with employee ID and skill. Hopefully that is making sense. And in this table, the primary key consists of employee ID and skill. And this is the foreign key. Now we can understand. Right. So for this ER diagram, we have to do this. Someone is asking, do we have to create a table for address? No. Only for multi-valued attribute, we create a new one. We don't have to create anything for address. We will simply use the components as an attribute. What about derived attribute? Derived attribute will go in here normally. Okay, there is no issues with derived attribute. So if age is there, we'll simply put age in here in the employee table. So there is no attribute name address. Yes, there will be no attribute name as address. So if someone asks for the address, we have to print out all of these four: street, city, state, and zip code. Okay. Employee ID is foreign key in skills. Yes, here employee ID is the foreign key. That's why we can see dotted underline in here. Okay. So we know now how to create employee table, department table, right? Now, how should I create this works in relationship table, right? Employee table will have TFN, name, department will have DID and name. Should I create a table for this relationship table? Should I create a table for works in? Depends on the cardinality. So if you remember last week we learned about one-to-one, one-to-many, many-to-one, many-to-many. Only if the relation is many-to-many, then for the relationship we will create a table. For these three cases, we will not create any table. Okay. Again, if the cardinality of the relationship is many-to-many, at that time we will create a table for this relationship. If that is not the case, that means that is not many-to-many, we will not create any table. Okay. Why? See one or two examples. These are very simple. Things will make sense. Okay. So in this case, what is the cardinality? Definitely many-to-many, because I don't have any arrow, I don't have any thick line, right? So this one is saying one employee can work in multiple departments. One department can have multiple employees. So that simply means many-to-many. Right? Since we have a many-to-many relation in here, then I'll first show you what do we have to do. We'll create one for employee. We will create one for department. For works in, if you remember last week we learned the primary key comes into works in from both sides. Right? So in works in table we will have the TFN number and DID. Have a look, hopefully making sense. One question someone is asking, so both composite and multi-valued attributes need to be separated. Composite, no. Multi-valued, yes. So if we have a multi-valued attribute, then we have to create a new table. If we have a composite, we will not write that composite attribute name, but its components. Someone is saying for the name, do we have to divide it into first and last? So in this case, this is not composite, right? So because I don't have any other link in here. So this one is showing that you will simply store only one name. If it was composite, then there would be another few other things, right? If that is not shown, that is a simple attribute, right? Should be very simple. Okay. What about if I have some attributes in this relationship table? Okay, so if I have relationship table in there, attributes in that relationship table, then it is understandable that those attributes will go to this relationship table as well, right? So in this case, student table will have the many, that time we have to create a table. All the other things we can illustrate without creating an extra table. Okay. Hello, can you hear me? It says cannot hear me. Now everything is good. Sorry about that. I'm really sorry. I'm not sure why this is happening. Keep happening. Okay. Sorry about that. What about now? Can you hear me now? Okay. Okay, I'll say again what is it that I was explaining? I was explaining if we have some extra attributes in the relationship table, where those attributes will go, right? So that is understandable in this case, since we are creating a table for enroll, because there is a many-to-many, right? So these attributes will go to this enroll table. We have to decide when we don't create this table enroll, let's say, at that time where this will go. But in this case, this is pretty simple, right? So let's say other cases. What sort of relation do I have? Have a look. Now I have an arrow there. In here, now I have an arrow. So what is the cardinality? One to one, one to many to one, many to many. Yes, you remembered? No, not exactly one. This is at most one. Right? So at most one means one employee can work in at most one department. On the other hand, one department can have many employees. Right? So in this case, the relationship is not many to many, and that means we don't need to create a table for work scene. Yes, right? So we don't need to create an extra table for work scene. So how do we put this condition there that one employee can work in at most one department and one department can have many employees? So now think about, we are not going to create an extra table for work scene. That simply means that I either have to take employee ID and put it into department to connect, or take this department ID and put it into employee. Which one is correct? Number one or number two? If I simply take DID and put it into employee table, will that one be correct? Or if I put employee ID into department, that one will be correct. Number one or number two? based on these two conditions. One employee works in at most one department, and one department can have multiple employees. Yes, all of you are saying number one. So what will happen in number one? Have a look. DID is the primary key. Okay. Department name and then employee ID. Will that work? Think about that. So this table consists of these attributes. So department ID is 101, employee ID, let's say E1. Can I write again 101? Because one department can have multiple employees. I need to write 101 again. Can I write that one? Definitely not, because DID is the primary key. Right? Think about the other way. Employee. In the employee table now I have employee ID, I have name, and I am trying to put DID. And in this case, employee ID is the primary key. So one employee, 101, he works in D01, let's say. That is fine. In D01, I can have another employee. Right? So now you can see that yes, one employee works in at most one department. I will not be able to duplicate because EID is the primary key. So if I want to write 101 again, that is not allowed. And that is also not allowed based on the condition. Right? So this is the correct one, hopefully making sense. So what I have to do, I have to put this DID, department ID, into this employee table to make sure of those two conditions. Now you can see that in this case, without creating an extra table, I can still enforce that condition. If I have an extra attribute since, where should that go? Definitely where I am linking, right? So I am linking in here. In this table, I have this employee works in this department. So there I need to put since when that employee is working. Hopefully making sense. Can we do this? Definitely not. That's what I tried to explain, right? That one will be wrong. What about this one? I have arrow on both sides. This is 1-to-1, someone said it, right? So if it is 1-to-1, then what can we do? Should we take EID to DID or DID to EID? Both are correct, right? I can take department ID and put it into employee table, or I can take employee ID and put it into department table. Both are correct because I have 1-to-1 relation in here. One employee can work in at most one department can have at most one employee. So at that case, either one will be fine. Hopefully making sense. Example, what does thick arrow and thick arrow means? Yes, thick arrow means that is exactly one. No, not at least, that is exactly one. Right? So how do we ensure that one, that it would be exactly one? We'll put DID into employee table like we did for at most one. Yes, someone said not none. Yes. So when we have that thingy, that it should be exactly one, then we'll simply put a not null on the foreign key. So if we write not null, so for that employee, there should be a department number there, right? So exactly one. not null on the foreign keys. Okay, so these are all the combinations that we have. Think about whether you can understand or you can define all of these. Okay, based on that, can you answer this one? Which one would be the correct relation in this case? From 1 to 6, which one would be the correct one? Someone said 5, someone said 6. Anyone else? Another one said 6. 5, 2, 5, 5. Yes, in this case, 5 will be the correct one. Right? So on duty is connecting 3 tables, doctor, ward, and office. That simply means 3 primary key will come, doctor ID, ward ID, and room number in here. So that is what we have in number 5. Doc ID, ward ID, and room number. To ensure at least, we'll simply put not null there. Okay. Weak entity set. Very simple. We already know about weak entity set. So in weak entity set, what do we have? We have a weak entity and weak relation. Okay. So for the weak relation, we will not create anything. Only for this weak entity, we will create one table. Okay. And if you remember from last week, we create the primary key of this weak entity set, combination of the primary key of this employee table and this primary key of. Sorry, everyone. My network is not supporting today for some reason. Okay. Are you TPG? No, I'm using NBN connection, but still it doesn't work. Sorry about that. Can you hear me now? Yes. So I will stop right here for today. Okay. Because this one is not going anywhere. I also have only 10 minutes. So I will stop in here. The rest of the part I will cover next week again.